Suddenly, a hidden truth about computer architecture reveals itself. All CPU instructions, no matter their complexity, can be reduced to a single operation, the shortest possible branch. One of the primary CPU design goals is to minimize instruction time, transforming them into a series of repetition loops. I discovered that floating point multiplication is essentially just a loop of repeated additions. Imagine that the CPU views storing a number like 2.5 as a series of 2s and 5s, essentially, a base 10 numeral system. The calculation results from the multiplication of a quotient, making this loop essential to our modern computing power. Deep within the CPU's control unit, I discovered that the comparison between the factor and the result is made possible by the shortest branch instruction handling. This handler quietly links each subsequent operation, whether it's a repeat or an alternative direction, with an abbreviated numerical identifier, a numeral that specifies the number of iterations, still all based on addition operations. Additionally, to further ensure high performance in hardware and surprisingly retain backwards compatibility for legacy code, the core CPU follows an optimized representation of our numeral. It renames the step into higher numbers until it iterates. What initially seems like a contrived operation becomes a time-saving treasure trove when factored into higher, redundant representations of the original operator, for example transforming a for loop into a single pump. Breaking it down, the artificial substitute fully handles the failed attempt's intrinsic main structure transformation from circuitry passage, amplifying what can only be a singular increment registerable instruction grouping.